so in this class we'll be talking about scenarios where we'll be modeling externalities. Okay, so externalities is a situation, let's say for example in a pure exchange economy, you can imagine that utility of a particular consumer is not just a function of his own consumption, but it is also a function of somebody else's consumption. Okay, so that's like a consumption externality. Okay, so you can imagine that kind of a scenario. Okay, so far, in the pure exchange economy, we haven't, done a scenario like this. Okay, we have only considered situations where your utility is just the function of your own consumption. Is that fine? So we'll be modeling scenarios where utility is not just a function of individual's own consumption, but it is also a function of somebody else's consumption. Okay, so that's like consumption externality. Okay, so let us consider an environment which is the pure exchange economy. Okay, so in this pure exchange economy, let's assume for the time being, let's just take the simplest scenario where there is only one good. Okay, so there is only one good. Okay, so you can imagine, maybe just to motivate this, you can imagine a scenario where there is only one good chocolate, and there are two consumers, Romeo and Juliet. Okay, so one good chocolate and two consumers, Romeo and Juliet. Okay, so so we want to figure out answers to all those questions. First of all, what will be the set of feasible allocations, and then what will be kind of efficient allocation. So we'll be talking about all that. Okay, so before I do that, we need to talk about the preference of Romeo and Juliet. Okay, preference of Romeo and Juliet. Okay, so preferences are, again, let's assume that there is a utility function that represents a preference. Okay, so the situations that we have seen so far, in the pure exchange economy, were the situations where a consumer is only affected by his own consumption, but not by the other person's consumption. Here we are introducing externalities. Okay, so and if you just see the characters in this model, they are Romeo and Juliet, and the good is chocolate. So don't you think that Romeo is affected by Juliet's consumption of chocolates? I mean, he should, right? In fact, he's going to gift her chocolates. Don't you think so? Okay, so I mean, he is affected by Juliet's consumption of chocolates, and same holds for Juliet, right? I mean, Juliet would also enjoy watching Romeo having chocolates. Okay, so so let's say utility function of Romeo is a function of Romeo's consumption of chocolate. Okay, and Juliet's consumption of chocolate. Okay, and Juliet's utility function is also a function of Romeo's consumption of chocolate and Juliet's consumption of chocolate. Okay, and let's start with some endowment. Okay, let us call omega r to be the endowment of chocolates with Romeo, and omega j to be the endowment of chocolates with Juliet. Okay, so omega r is the endowment of Romeo. Okay, and omega j is Juliet's endowment, okay, of chocolate. Is that clear? Okay, so this completes a description of the model. Okay, we have this pure exchange economy, one good, two consumers, their preferences, and their endowment. Okay, so this completes the description of the model. Now we are in a position to figure out, basically answer questions like this. What is feasible, what is efficient, what is the competitive equilibrium. Okay, so what I'll do is, I'll first tell you how to represent this kind of environment in a graph. Okay, and then we are going to see how to figure out Pareto efficient allocations. Okay, and then we can also talk about what will be the competitive equilibrium, and and then we can talk about whether competitive equilibrium is efficient or not. Okay, which is whether first welfare theorem holds or not. Okay, so let's do some examples. Okay, so so the first thing that I'm going to do is I'm going to pick some endowment of Romeo, some endowment of Juliet, and I'll tell you how to actually plot or basically represent in a picture the set of all feasible allocations. Okay, so that is the first thing that we are going to do. So let's consider this example economy where let's say omega r is 2 units and omega j is 3 units. Okay, so Romeo has 2 units of chocolates, Juliet has 3 units of chocolates. Okay, now I want to represent this set of all feasible allocations using some picture. Okay, first of all, let me write what is set of all feasible allocations in this case. So set of all feasible allocations is CR CJ in R2 plus such that CR plus CJ must be equal to omega R plus omega J, which is 5, right? Because any pair CR CJ is said to be feasible if the sum of the consumption of the chocolates in that pair CR CJ must be equal to the total endowment of chocolates in the economy, which is 5 in this case. Is that okay? Okay, so that's feasible allocations. Now you can plot this. Okay, using the same setup. You already know how to plot set of all feasible allocations. You know the Edgeworth box, but here we just have one good, so we don't need any height in the box. Okay, we can just draw a line, and then line will represent the set of all feasible allocation. If you want, you can call that Edgeworth line. Okay, so so let's draw the Edgeworth line. Okay, so this is the origin of Romeo. You can say this is the origin of Romeo. In this direction, the amount of CR is increasing, and this is the origin of Juliet. And in this direction, you can say that CJ is increasing. Okay, and the length of this line segment OROJ is 5. Okay, because the total number of units of chocolates in this economy is 5. Okay, by the way, we are assuming that chocolates are perfectly divisible. Okay, so chocolates are perfectly divisible. So what that means is you can also consume fraction of chocolates, or basically in any quantity. Okay, you can consume chocolates. Okay, so any point here represents a feasible allocation. So like for example, if this is the point that we are talking about, then this means that this length is the amount of chocolate consumed by Romeo, and this length denotes the amount of chocolate consumed by Juliet. Is that clear? Okay, so obviously if you just keep moving this, if you move from this point to this point, then you are increasing the Romeo's consumption of chocolates and reducing the Juliet's consumption of chocolate. Okay, and if you move leftwards, basically the opposite happens. Okay, so this is how you can represent this in using the Edgeworth line. Okay, so let us now figure out for some pair of utility functions the set of all efficient allocations. Okay, so UR is, let's say, let's say it is kind of perfect complements, okay, and let's say Romeo want Juliet to consume more, okay, so it's perfect complement case, but Romeo want Juliet to consume more. So can you tell me what kind of utility function should I use so that I get this kind of preference? Okay, yes, so it should be, it should, you know, yeah, I mean the min will work, okay, okay, and what do you think? Should I put 2CR or CR2CJ? Okay, let's say you know, Romeo uh, likes Juliet to consume more, okay, 2CR CJ. That's, yeah, that's going to work, okay. Okay, so let's say Juliet you know, also has this perfect complement kind of preference where, you know, the utility function is min CR2CJ. Is that fine? Okay, now let us figure out set of all efficient allocations. Okay, so how do we find set of all efficient allocations in this economy? What do you think? So in order to figure out set of all efficient allocations, what we can do is we can plot the utilities. Okay, so let me just correct this statement. Okay, we'll not be plotting exactly the utility function here. Okay, we'll be plotting something called adjusted utility function. Okay, so because you know, what we are interested in is we are interested in the Pareto efficient allocations. Okay, so when we are talking about Pareto efficient allocations, so if you remember, we say that a feasible allocation is Pareto efficient if there is no feasible way in which you can make one consumer better off without making the other consumer worse off. So feasibility is something which is you know which is already there in this definition. So basically, you know, when we are talking about Pareto efficiency, we are actually comparing one feasible allocation with the other feasible allocation to determine you know, which allocation is Pareto superior to the other, right? Okay, so you know, you can actually rewrite this utility function, okay, assuming feasibility constraint, okay, assuming feasibility constraint holds. So if you rewrite this utility function assuming feasibility constraint holds, you will get, you know, what you can call this UR adjusted. Okay, UR adjusted for feasibility. So what is UR adjusted? Okay, so UR adjusted is just a function of CR. Okay, so it's now one variable. You know, it's just a function of one variable, which is Romeo's consumption of chocolate. Okay, and how is this dependent on the Romeo's utility function? So what you have done is you have replaced CJ by 5 minus CR, because when we are talking about feasible allocations, CJ must be exactly equal to 5 minus CR. Do you agree? Okay, so notice that now you have everything in terms of CR, and that is why this is just a function of CR. Is that okay? So now I can just rewrite this, okay, by replacing CJ by 5 minus CR in the following way. You're going to get min of 2CR comma 5 minus CR. Okay, and similarly you can do the same thing for the Juliet. Now this is you know, very simple. You know, we can easily draw this, right? This is just a function of one variable. We can easily plot this. Okay, so I'm going to plot UR CR in this you know, in this plane. Okay, so let's call this UR. Okay, and let's say that, you know, we are also measuring uj adjcg on the vertical axis. Okay, so we have u. Is that fine? Okay, now I'm just going to simply plot the graph of U. That's all that you need to do. Okay, I mean, this is just very simple. Okay, so can you tell me how is this going to look? When CR is 0, this is 0, right? And when CR is 5, again this is 0. So these are 2 points, okay, that will be there on the graph of the utility. Okay, and when 2 CR is less than 5 minus CR, which means that 3 CR is less than 5, which means that CR is less than 5 by 3. Okay, so 5 by 3 is somewhere here, right? So this is 5, so this is approximately 5 by 3. Okay, okay, so this is 5 by 3. Okay, and then all that you have to do is you just have to plot the graph of 2 CR for CR less than 5 by 3, right? So that's basically just a straight line like this. Okay, and then it is going to look like this. Okay, because after that it is 5 minus CR, right? After for CR greater than 5 by 3, it is 5 minus CR. Yes or no? For CR less than 5 by 3, I've just plotted 2 CR. So the slope of this line is 2. Okay. For CR greater than 5 by 3, I have plotted 5 minus CR. So the slope of this line is 1. Okay. In absolute terms. Okay. And it's a continuous function. So there'll not be any discontinuity at this king. Okay. Is that fine? Okay, now by symmetry, you can, because it's just the symmetric utility function from the Juliet's perspective, you can do the same thing for the Juliet, right? So Juliet will have preference, which can be represented in this way. Okay, of course assuming feasibility. And what is this point? This point must be 5 by 3 from this direction. So if it is 5 by 3 from this direction, it is 5 minus 5 by 3 from this direction, right? So 5 minus 5 by 3 is what? So it is 10 by 3, right? So this point is 10 by 3. Is that clear? Okay, now that's actually kind of straightforward. Okay, once you have plotted the utility functions, now you can just compare, you can just check what is efficient allocation and what is not efficient allocation. So you already know the definition of efficiency, so we can quickly do the check. Let's look at this point. Tell me, is this point efficient? This is not efficient. Very good. So this is not efficient because you can actually improve the satisfaction level of both the individuals by moving to a point in this direction. Is that okay? Well, somewhere here, okay, between this and this. If you move to a point between this and this, you will definitely make both of them better off. You can see that the utility is higher for both Romeo and Juliet if you move from this point to this point. Is that clear to everyone? So this allocation cannot be efficient, and the same logic applies to all allocations which are less, where CR is less than 5 by 3. So no allocation where CR is less than 5 by 3 is efficient. Okay, by symmetry, no allocation where CJ is less than 5 by 3, or you can say CR is greater than 10 by 3 is efficient. Okay, so we have already ruled out this and we have ruled out this. Now these are the only ones that are left. Okay, and now let's check here. For example, is this Pareto efficient? That's right, very good. Okay, it is Pareto efficient, because if you move to the right, you will end up making what? You'll end up making whom worse off. So basically, if you are at this point and you give more chocolates to Romeo, Romeo will be worse off. Romeo at this point will say, okay, I would want Juliet to consume more chocolates. Okay, right? If you are at this point, you increase Romeo's consumption of chocolate, Romeo will be worse off because he would want Juliet to consume more. Okay, and if you move to the left, Juliet will be worse off because Juliet would want Romeo to consume more. Make sense? Yes or no? Can you see the romance here? Yes. Okay, so clearly this is Pareto efficient, right? And not just this point, all these allocations are Pareto efficient because of the same logic. Make sense? Have you all understood this? Okay, so now you can just write the set of all Pareto efficient allocations in this way. It's CR CJ belonging to F, okay, such that CR is between 5/3 and 10/3. All these allocations are Pareto efficient. Okay, so all the feasible allocations that satisfy this property are Pareto efficient. Is this clear to everyone? Okay, by the way, there is another way to do this problem. I mean, this is one way in which you can just plot it and do it. Other way to do this problem is, if you just look at this problem, just look at it. Just think about, if you just let Romeo choose, okay, these are the 5 chocolates, and you ask Romeo, okay, what is the best division, according to you. What do you think Romeo will say? So if you just let Romeo divide the chocolates between Romeo and Juliet, what do you think Romeo will do? So out of these 5 chocolates, how much will Romeo consume and how much will he give to Juliet? So Romeo will say that, okay, I'm going to consume 5/3, and I would want Juliet to consume 2 times what I'm consuming, okay, 10/3. Okay, so this is the best point, best allocation from Romeo's perspective. Is that okay? Yes. Okay, so obviously this allocation is definitely going to be, as you can see, Pareto efficient, because any movement away from this allocation will definitely make Romeo worse off. So this allocation is definitely Pareto efficient. You can do the same thing. You can ask the same question for the Juliet. So if you let Juliet decide, out of these 5 chocolates, how many chocolates should Romeo consume, and how much of the chocolate she consumes for herself, okay, then you will find that she'll say that, okay, I want 5/3 units of chocolates, and I would want Romeo to consume 10/3. Okay, so you can see, what is going on here. Romeo want Juliet to consume more, Juliet want Romeo to consume more. Okay, and that's where these peaks are. Okay, this is Juliet's peak, and this is Romeo's peak. Okay, and any point to the left of 5/3 would mean that, Romeo is consuming little too less. Okay, so he also likes chocolate. It's not that he doesn't like it at all. Okay, he likes it. Okay, it's just that it's just that so it's this kind of we have perfect complement situation, okay, where he would always want Juliet to consume twice more than himself. Okay, so that's basically his kind of ideal, the best point, okay, where Juliet consumes twice more than himself. So if he's consuming too less, in that situation, what happens is that too less means that, let's say if he's consuming less than half the number of chocolates that Juliet is consuming, in that case, he would want some chocolate for himself, right? Okay, he would prefer that if Juliet can give some chocolate to him, he would like it. Okay, and if you just do the same thing from the Juliet's perspective, Juliet would want Romeo to consume twice more than what she's consuming. Okay, but in this scenario, Romeo is consuming way less. Okay, even less than what she's consuming. So obviously Juliet would also want Romeo to consume more. So both would want Romeo to consume more, because Romeo is consuming way too less. Okay, so clearly, if you just take some chocolates from Juliet and give it to Romeo, both will be better off. Is that okay? And similarly, you can just do the same thing here. Just by using this kind of story, you can just figure out that these allocations are also not efficient. Okay, and if you check out in this range, that's where the romance happens. Okay, once they are consuming beyond this threshold 5/3, both are consuming more than 5/3, Then Romeo would want Juliet to consume more, Juliet would want Romeo to consume more, and they'll just try to give chocolate to each other. Okay, and that is why all these allocations are Pareto efficient, because if you take chocolate from Romeo and give it to Juliet, then Juliet would say, no, no, I don't want it, let Romeo consume it. Okay, and if you take chocolate from Juliet and give it to Romeo, then Romeo would be worse off, because Romeo would say, no, 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 Juliet should consume it. Okay, so that's basically what's going on. So all these are Pareto efficient. Can you see this, all of you? Have you understood this? Okay, very good. Okay.